found this old book during the summer. I was cleaning out my garage, and so I opened it. I wanted to see what it was about. It's called Earth Story, a scientific tale about the formation of the Earth, how the Earth was made.
Is there any picture?
Here's how the story goes. A long time ago, there was nothing. Nothing. No stars, no mountains, no earth. Nothing. There was only a great space which had no beginning and no end. There was darkness and coldness, and there seemed nothing more. But when we think of darkness, we think of night. But our night would be like brilliant sunshine in comparison with that darkness. When we think of cold, we think of ice. But ice would be positively hot compared with the coldness of space. There were little particles like dust, hydrogen particles, drifting in the vast emptiness of space. At a certain moment, we don't know why or how, the particles united. And at that moment, when the particles united, there appeared a great light. It appeared something like a vast fiery cloud, which included all of the stars in the sky. In fact, the whole universe was in that cloud. And among the tiniest of stars, lost among billions of particles, was our own world. But the particles were not stars yet, only light and heat. So intense was the heat that all things we know existed as a gas, as thin as air. Iron was a gas, gold was a gas, rocks were a gas, everything. But at last they were fused together in one vast flaming ball of light and heat, a heat so intense it would make our sun feel like a piece of ice. This raging fiery cloud of energy, too huge to imagine, expanded and enlarged the darkness of space. And as it grew, it created the universe. The cloud of light and heat continued to move, leaving in its path tiny drops of matter. These great drops were to become the stars. One of these drops was our sun. But they were not falling in space. Instead, they were moving away from each other. In paths that would never allow them to meet. Today they are millions of miles apart and getting further apart with each passing second. Okay. Go ahead. Indeed, the stars are so far away from us that it takes the light of some of them millions of years to reach us. Do you know how fast light travels? 100 miles per hour? 200 miles per hour? 1,000 miles per hour? No, much faster. It travels 186,000 miles per second. Imagine how fast that is. 186,000 miles every second. That means that in 1 second, a beam of light could travel around the entire Earth 7 times. And do you know how big around the world is? It's 25,000 miles. If you were to drive 100 miles per hour all day and all night without stopping, it would take us more than 10 days to circle the Earth. But light can make that same trip 7 times in a single second. In the time it takes to snap your fingers, light has circled the globe 7 times. So you can imagine how far away some of the stars are if it takes their light 1 million years to reach us. At a certain moment, the turbulent cloud that was to become our sun drew in many particles of dust and gradually made itself into a center of gravity. As the sun spun, it flattened like a plate and rings formed around it. In these rings were denser particles that came together. Once they became centers of gravity, they grew heavier and hotter. One of these swirling, spinning circles of growing particles was the planet Earth. When you think about it, the sun doesn't look so big, but that's because it's so far away. In fact, the sun is 1,000,000 times bigger than the Earth. If you can see this little dot right here, that's the size of the Earth if you compare it to the sun. It's so big that a single flame could hold 22 Earths.
22 Earths.
Hold on, I'm going to tell a little more story. Every scrap of the universe, every speck which we might think too tiny to matter, had a set of scientific rules to follow. Little particles like smoke or air followed the rule that said, as you become cold, you will come closer and become smaller. And so, as they cooled, they moved more and more slowly, clinging more closely to each other, occupying less and less space. The particles assumed different states, which humans now call solid, liquid, and gas. Felix?
As you can see, we have ice, and this is a solid. You can't put your hand through it. As you can see, this is a liquid, water. You can put your hand through it. Air is a gas.
This ball of gas, as it rotated in space, began to cool. There was a difference among the particles. Some particles were attracted to each other, others were not. Because of this, particles combined and began to form themselves into different groups. Felix, in the solid state, particles cling so closely together that they are almost impossible to separate. They form a body which will not alter its shape unless one applies great force or heat. If a piece is broken off, the particles still cling together and remain solid pieces of stone. As for the liquids, those particles hold together also, but not as closely. They have no shape of their own. Since the particles don't cling together closely, liquids assume the shape of the container they occupy. Liquids flow and spread. They fill every hollow, crack, and valley in their path. Liquids push sideways and downwards, but never upwards.
Yeah.
As for the gas particles, their rules said, you will not cling together at all. You will move freely in all directions. Gases push downwards, sideways, and upwards. Very exciting. So then I turned the page, and here's what it said. As the particles were also separate individuals, they did not become solid, liquid, or gas all at the same time. At a certain temperature, some remained solid, others became liquid, and still others became a gas. So let's see, I just made this hot. Let's see what happens if I apply heat to some different things. Let's see. I'm going to put my hot plate there. This is a liquid. This is water. I need to warm this up just a sec and see what happens if I apply water to heat.
It makes fire.
You think it'll make fire? Okay, that's a good hypothesis. We'll see.
It's going to boil.
You think it'll boil? Okay, now listen carefully. We might hear something. Ready? Listen. Did you hear that?
Steam.
I'm going to do it again. Ready? Okay, so wow, that made steam or gas. Everything is solid, liquid, or gas. So that was a liquid and it turned into a gas. Now, I'm going to put a different tray. What's this? Crayon. Is it a solid, a liquid, or a gas?
Solid.
I'm going to apply heat to it and see what happens.
It's gonna melt. It's gonna melt.
Here I go. I put my crayon in.
Add water.
Oh, I see gas coming up. Let's see. Something's changing. It doesn't look like a crayon anymore. Can you smell it?
It's melting.
It's melting. It's turning into what? Is it turning into a solid, a liquid, or a gas?
A liquid.
Watch this. So what did heat make it turn into? That's right. All right, I think I'll try one more.
A gas.
Have this wire. Is this a, wait. Is this a solid, a liquid, or a gas?
Solid.
Right, let's see. I'm going to apply heat to it. Here I go.
Let's see if it melts. It's in the mouth. It's in the mouth.
Oh, something's happening.
It's getting smaller.
It's getting smaller.
It's smaller. It's shrinking.
It's turning into...
Oh my God, there's smoke.
Oh, wait a minute. I have to show you what happened. I'm going to turn off my heat source because I'm finished with that. So I have some water here, and I poured that liquid crayon into the water, and look what I got. It turned back into a solid. And you won't believe this. That piece of metal, it's called solder. It turned into a liquid, and then I poured it into the water, and look at it now.
Whoa. It's metal. Yeah. It's metal.
All right, you can sit back down.
Metal.
I think there's one more page in my story. Let me check.
Add the file in there.
So will you let me finish, and then we'll have a talk after. So not only does heat change things from a solid to a liquid or a gas, Michael, the particles also have different weights. So let's see. He's going to put some liquid into the test tube. And a different liquid. What do you think will happen? He's got a yellow liquid and a green. Let's give him a second to think, Michael. A yellow liquid and a green liquid.
I can't see.
Let's see.
Light green?
Maybe. Okay, let's give it a shot.
It did make go.
It didn't.
Separated. It's Bob. Lovely color. It's like golden. What? It's going to the bottom. Oh, separated.
Wow. And so the heavier liquid went to the very bottom. And when the earth was being formed, heavier particles went near the heart of the earth, and lighter particles floated on top, like oil floating on water.
Including us.
For hundreds and thousands and millions of years, this dance went on. Finally, the particles settled down.
Smelling.
They became liquid and then solid, and as they became solid or liquid, some joined others to which they were attracted, forming new substances. Different parts of the earth was formed. Molten iron sank to the center. Minerals such as quartz, mica, and feldspar formed the mantle. The surface was hot basalt, and here and there, volcanoes erupted lava.
Ooh.
Patches of granite floated on the basalt. Since the earth was small, it cooled more quickly. The stars, being larger, are still today giant balls of fire. Felix, leave it for today, honey. That was just yesterday. The earth cooled and became viscous and solid. When the earth grew to its present size, it formed an atmosphere. Moisture was squeezed out of the rocks and covered the earth in thick clouds. The particles that rose cooled and fell back, bringing some cool from above. Gradually, the earth cooled and formed a crust. So this is what if you were walking on the earth, then this would be what the ground was like. Ready? Yeah. It wasn't solid yet. It was just a little bit of a crust with hot steam inside.
Yuck. No, I think yuck.
A thin skin was formed, like the skin which forms on milk when it is boiled and left to cool. Rains began to fall, and storms of great fury raged over the land. The crust formed over the earth, and the fire within wanted to get out. The elements inside the skin were still very hot. I'm sorry, you did that early, and that was my fault. They felt trapped. They wanted to get out. What could they do otherwise? They had to follow their own rule that said, if you were hot, you expand. You can do it again. There was no place to expand, so they broke out through the newly formed skin of the earth as volcanoes. The volcanoes helped to form a great cloud cover over the earth, which hid the sun. Then the earth cooled faster. The rain fell, and when it hit the earth, it vaporized like a drop of water hitting a pie tin. The crust cooled even more. Eventually, the great explosions and fires ceased. As everything cooled down, more and more gases became liquid, more and more liquids became solid. The earth itself shrank and became wrinkled like an old apple that has been left in the cupboard. This is an apple. And it's all shriveled up, and it's all wrinkled. And these wrinkles are like the mountains and the valleys of our great oceans. For as soon as the rocks had cooled down, water was able to return to the earth. And it rained and rained and rained. And the water being liquid filled every valley and crevice it found in its path. Thus the ocean was formed. Above the great ocean there was air, the air we now breathe. The cloud cover disappeared, and once again the sun could smile upon the earth. The end. You can stop filming now.